Yes, sir.
Diagram of effect of rotation on weight. Once again, we'll see that diagram. Effect of rotation on acceleration due to gravity or weight. I'm just explaining that diagram once again. Effect of rotation on G or weight. If body is on latitude. Already diagram you have drawn. Once again, I'm explaining. If this is Earth, this is called equator. This one is line passing through whole geographical axis. Consider a body of mass m situated on the surface of Earth having radius r, mass capital M, on latitude making angle theta with the equator. When Earth rotates with angular velocity omega, then the body of mass m performs rotational motion of radius small r equals to r cos theta, because this is theta, this is theta. Forces acting on the body are its weight mg towards the center of Earth and centrifugal force m omega square r. Centrifugal force m omega square r can be resolved into two rectangular components. M omega square r cos theta radially outwards from center of Earth, and m omega square r sin theta tangential to the Earth. I think this much you have drawn the diagram.
Yes.
Okay. Now see, if you see carefully, mg is acting downward and m omega square r cos theta is outward. So where will be the net force? Can you tell me? Outward or inward? Net force? Hello? Where will be the net force? Outward or inward? The net force is outward, then body will fly off. So it has to be inward, na?
Yes, sir.
So can I say apparent weight mg dash is actual weight acting downward mg minus m omega square r into cos theta. That means mg dash will be mg minus m omega square, small r is r cos theta into cos theta. So apparent weight is mg minus m omega square r cos square theta. Have you followed this concept?
Yes.
Yes.
Now write down. I'm clearing everything. Diagram everybody has followed once again. Yes, Akansha, diagram part followed. Harshita, Nija.
Yes, sir.
Right. Consider a body of mass m to be situated on latitude of Earth at an angle theta, on latitude at an angle theta, situated on latitude of Earth at an angle theta. Let capital M, R be the mass and radius of Earth. When Earth rotates with angular velocity omega, then body of mass m performs circular motion of radius small r equals to capital R cos theta. Small r equals to capital R cos theta. Then
Yes, so
huh?
Done, sir.
The forces acting on the body are first its weight mg towards center of Earth. Second, m omega square r radially outwards. M omega square r can be resolved into two rectangular components. A m omega square r cos theta radially outwards from center of Earth. M omega square r sin theta tangential to Earth. Please copy this much. M omega square r sin theta tangential to the Earth.
Done, sir.
Done? Everybody is done till this?
Yes, sir.
Oh, okay. Therefore, from the figure apparent weight, comma, mg dash equals to mg minus m omega square cos theta. So mg dash equals to mg m omega square, small r is r cos theta into cos theta. So mg dash is mg minus m omega square r cos square theta. This is expression for apparent weight, or g dash equals to g minus omega square r cos square. So that means effect on weight or gravity is same. Please copy till end. Then we will see what will happen if the body is at equator or at pole. Yes, done. Completed?
Yes,
Okay. At equator, can you tell what will be theta? At equator, what is theta?
180 degree.
No, 0 degree, na?
Yes, sir.
Yes, sir. Yes.
Theta is 0 degree at equator. So cos theta will become cos 0 and cos 0 is 1. Okay. Hello? Cos
Yes.
theta will be cos 0 is 1. That means mg dash is mg minus m omega square r into cos square theta will become mg dash equals to mg minus m omega square r into 1. That means mg dash is mg minus m omega square r at equator. Hello?
Yes.
So at equator, can I say mg dash is mg minus m omega square r?
Yes.
Yes, sir.
Now, for weightlessness at equator, weightlessness means mg dash should become 0.
Yes.
So can I say mg minus m omega square r is 0? Therefore mg will be m omega square r. Not followed?
Followed, sir.
So omega is root of g by r. That means actually I want to find what is omega if body is having weightlessness at equator. G is nothing but you can write approximately 10. Radius of earth is 6400 kilometer, which is 6.4 into 10 raised to 6 meter. So it will become 100 upon 64 into 10 raised to minus 6 in root. Okay.
Yes, sir.
100 square root is 10. 64 is 8 into 10 raised to minus 3. This is 5 by 4 into 10 raised to minus 3. So 1.25 into 10 raised to minus 3 radian per second should be the speed if the body feels weightlessness at equator. Very important MCQ type question. Copy now. Full.
No.
Yes, done till that you are saying? Hello, completed?
Yes, sir.
Now at poles, we'll see what will happen. At poles, what is theta at pole?
180.
90 degree. So what will be cos theta? It will be cos 90, which is 0. So mg dash equals to mg minus m omega square r into cos square theta. That will become mg dash equals to mg minus m omega square. This is 0. So mg dash equals to mg. So the rotation of Earth has no effect on weight if body lies at poles. Right. Yes, done.
Yes, sir.
So all G wala factor we have completed. G at surface, G at height, G at depth, very close. 2-3 sums relation. Next heading, right? Satellite. Any lighter body, which revolves under gravitational influence of planet is called as satellite. Any lighter body which revolves under gravitational influence of a planet is called as satellite. Right definition of satellite? Yes, completed.
Yes.
Now one very good derivation we are doing. Mostly chances are there it may come in the exam. Define, one second. Define critical or orbital velocity. And derive its expression. Important derivation. Right heading? Derive critical velocity or orbital velocity and derive its expression. Heading written? Hello, heading you have written?
Yes.
Now suppose this is Earth. Then satellite to be launched is taken vertically upward and then it is fired horizontally. Every time it will not revolve. If it is revolving, then that velocity is called critical velocity. Horizontal velocity is called critical. If it is not revolving, what will happen? That we'll see later on. So the minimum velocity with which satellite at certain height above Earth's surface must be projected horizontally so that it revolves in circular orbit is called as critical or orbital velocity. Definition followed? The minimum velocity with which a satellite at certain height above Earth's surface must be projected. Minimum velocity with which a satellite at certain height above Earth's surface must be projected horizontally, so that it revolves in a circular orbit is called as critical or orbital velocity. Please write full. the minimum velocity with which a satellite at certain height above Earth's surface must be projected horizontally so that it revolves in a circular orbit is called as critical or orbital velocity. Yes, can I clear this definition?
Yes, sir.
It is called as critical or orbital velocity. Now derivation we want. So this is Earth. Consider satellite of mass m at height h above Earth's surface of mass capital M, radius r, to be projected horizontally with critical velocity vc so that it revolves in a circular orbit of radius small r equals to r plus h. Draw diagram. Consider satellite of mass m at height h above Earth's surface of mass m, radius r, to be projected horizontally with critical velocity vc so that it revolves in circular orbit of radius small r equals to r plus h. Draw the diagram. Diagram done?
Yes, sir.
Right. Consider a satellite of mass m at height h above Earth's surface, having mass capital M, comma radius capital R, to be projected horizontally with critical velocity Vc so that it revolves in circular orbit of radius small r equals to r plus h. Copy now. Yes, done till this?
Yes.
So we have done considered satellite of mass m at height h above Earth's surface having mass capital M, radius capital R to be projected horizontally with critical velocity Vc so that it revolves in circular orbit of radius small r equals to r plus h. Satellite is performing circular motion or zigzag motion?
The circular motion.
Circular motion. Uniform or non-uniform?
Uniform.
Uniform, yes. So as the satellite performs uniform circular motion, that means UCM, it requires centripetal force, correct na? To move in a circle we require centripetal force provided by gravitational force of attraction, provided by gravitational force of attraction between satellite and Earth. So since centripetal force equals to gravitational force, what is formula for gravitational force? G into product of mass upon square of distance. Gmm upon small r square. And centripetal force is m Vc square upon r for that satellite. Formula clear? Formula? Hello, formula is clear with you?
Yes, sir.
M small we can cancel from both sides. 1 r we can cancel. So I get Vc is root of G m by r. This is an expression for critical or orbital velocity. Right now. Right, till end. Completed? This is an expression for critical or orbital velocity. Which satellite speed will be more, lighter or heavier?
So the lighter one speed will be more.
Who is saying this, Mank? You are saying?
Yes,
Sir,
sir.
heavier mass.
Can you see in the formula there is no mass of the satellite?
Oh,
So very
right.
important. वजन पे नहीं depend करता है. तो नीचे लिख दो. It is independent of mass of the orbiting satellite. Very important. Generally, we may say it is dependent. It is independent of mass of orbiting satellite. Okay, everybody's done. Can I clear it off? Next heading, right? Time period of satellite. Time period of satellite. What is meaning of time period? You have studied in 9th, 10th, time period of wave. Time taken by anything to do that. Time taken to complete one revolution, one oscillation, one vibration, all are called time period. So I will say time taken by satellite to complete one revolution around planet. Time taken by satellite to complete one revolution around planet is called as time period of satellite. Right definition. Time taken by satellite to complete one revolution around planet is called as time period of satellite. हेलो अच्छा चलेगा अभी ऊपर होगा ना ले लो चलेगा ले लो चलेगा कितना आएगा उसमें 100 भी आ सकता है 200 नहीं फिर वो ये करता है ना वो अभी अपना वायलेशन एक्ट करता है ध्यान दो हाँ 100 तो ले सकते हैं हाँ 100 ले लो चलेगा हाँ ठीक ठीक है हेलो कंप्लीटेड Hello.
Yes, sir.
So we got time taken by satellite to complete one revolution around planet as time period of satellite. Next heading, right? Derive expression for time period of satellite or show that t square proportional r cube. T square means square of time period, r cube is orbital radius. Very simple derivation. Consider a satellite of mass m. Consider a satellite of mass m consider satellite of mass m revolving in a circular orbit of radius small r with critical velocity vc around Earth of mass capital M, radius capital R. Therefore, distance covered in one revolution. Distance covered in one revolution means circumference. Correct, na? Distance covered in one revolution is circumference, which is 2 pi r. Okay?
Yes, sir.
Yeah. So just copy till this. Distance covered in one revolution equals to 2 pi r. Can I clear this now?
Yes, sir.
Okay. Then since speed equals to distance upon time, so Vc will be 2 pi r upon capital T. So root of G capital M upon R is 2 pi r by T. So T equals to 2 pi r into root of R by Gm. Therefore, T equals to 2 pi. R goes inside root. Will it become R square then? A, can I write root of A square? B, can I write root of B square?
Yes, sir.
R, can I write root of R square? Correct, na? So it will become
Yes,
R
sir.
cube upon Gm. This is expression for time period of satellite. Just copy this, then two more line because we have to show that T square is proportional to R cube. Copy this much. Done?
Sir.
Okay. Now squaring both the sides, we get t square equals to 4 pi square into r cube upon gm. Since 4 pi square upon gm is constant, therefore t square equals to constant into r cube. So t square proportional r cube. Copy now till last line. Get it now?
Yes, sir.
Okay. So that's all for today. This Sunday test will be on MCQ